Lesson 43 is the area of a regular polygon. So of course my regular polygon is that shape that is perfection, right? Equal sides, and every single vertex has the same angle. Now the only thing you have to add to what you don't know is a little a here for apothem. Your side we already used, and your n we've been using the whole chapter. So this lesson actually wraps up the whole chapter. So the only thing that's new, for example, this one, n would be 5, and maybe they would tell you that your side length is a 3. The only thing I'm missing here now is your apothem, which is right in the middle, straight through the side. This is your little a, it's your little apothem. It's almost like an imaginary height. It is not the radius. This to the corner would be your radius. So a little bit longer, your radius than the apothem. So you have to know the little a, the s, and the n, because that actually builds on to your formula. Okay, I don't like the x's there, so I really like to use S-A-N, san divided by 2. Now remember that perimeter is really S times N, and then here they're saying times apothem. So it doesn't matter which way you multiply it up, it does multiply and then divide by 2 the exact same thing. So example number 1 is a straightforward one. It's just asking you, okay, we have lots, and the question is asking you, it doesn't ask you here, but I'm going to tell you, what is the area? So we're not talking about a circle, a square, a trapezoid, a kite. Here I have a regular pentagon. They do have to tell you that it is regular pentagon. Okay, so I know that every single side's the same. They have given me the side is a 4, your little apothem, which could be here, but remember that an apothem could also be anywhere. As long as it's a center, you could also have the apothem like upside. Most of the time it's straight up and down, but it could also be like this. That's your apothem. So your apothem here happens to be 3 centimeters, your side is a 4, and we know that n is equal to 5 because it's a pentagon. And they're asking you for area. Easy. Multiply that up, divide by 2. So your area here, your S, your side is a 4 times apothem, 3, and your n is your shape, it's 5, divided by 2. So multiply all that up. Your area here, if I multiply all the top, it's going to give me a 60. Divided by 2, I get 30. And of course, if it's area, the question is talking about centimeters. It's area, centimeters squared. That's going straight forward. Same formula, but we do have to know how to manipulate this formula backwards. So for example, they're giving you apothem is 8. They're telling you that it is a hexagon, so that's an n is equal to 6. And they're giving you the area is 48. They want to know what the s is, the side length. Easy. Use your formula, fill everything in. Your a is 48. Divided by 2 never changes, and I have 3 things I'm multiplying up. My s is what is missing. That's your x. Your a is 8, and your n is your hexagon. So how do I solve this? This should be, at this point, guys, the baby equation to solve. So I'm just going to rewrite it over here to the right. So my first step, I would definitely multiply my 8 and my 6 together. 48. Maybe you want to do that in one shot. 48. Maybe you want to go 48 divided by 2 right away. Your s, and that would give me a 24. You could definitely move the 2 over if you want. It really depends on how you want to solve it. Last step, I want the 24 gone. Opposite of multiplying is dividing each side by 24. So my s, my side length, is equal to 2. Now I'm keeping it backwards because we should at this point know how to manipulate those formulas backwards also. If you prefer, obviously, you could do 48x, which is your s, divided by 2 is equal to 48 on this side. So that's what we would have seen in algebra chapter, right? A little bit cleaner, but it's the same thing. Now, decomposable shapes. So if I have a weird shape, so let's say I have a hexagon and it's kind of like attached to a triangle here, and maybe on top here it has like a trapezoid. Now, I don't have a magic formula for all these shapes together, right? If I had a magic formula, that would be incredible, but I don't. But I can definitely do this, right? I can find the area of this guy. I can definitely find the area of a trapezoid, and I can definitely find the area of a triangle. So I would have to do that, 3 different formulas, and just add everything up, right? I have all those formulas: pentagon, trapezoid, and a triangle, and I just put everything back together to find your total area.